let's take this default image of face stretch as an example. As you can see here, if you pin the face stretch node to the graph and then you connect it to the face stretch info, you can get the information of the face stretch. Basically, you can get the default information like which phase or intensity from the tool, but you can also get more important information for those key points. Yeah. For example, we have 4-point array for you to use. The name could be, it looks similar, but they're all very different. So the first 2 key point array is the sample points in this particular screen space. And this screen space is normalized to the 720 and 100, which is the size of this particular image we use as a template. Yeah, but that template's position is normalized to 0 and 1, so you don't need to worry about the actual screen size of the render texture. Yeah, so these point array will always be their position in the screen space. But what if I want to preview where the actual deformed point is in that follows your face movement? Then we need those points called stretched view key points or initial view key points. Those points are the points that gets projected to your face movement, and it moves along with your face in the real time. Yeah, I think most of the time, if you're creating a face stretch effects, let's say by manipulating the points in the template space, you can just use the stretch sample key points and initial sample key points as a reference. Yeah. And also because the set face stretch node is using the stretch sample key point. So you may also want to notice that it's a good practice to only modify the sample key point and set them back, not modify the viewed key points and set them to the face stretch components. Yeah, otherwise it will be like you will see that the screen coordinates will not match. Yeah. And yeah, apart from that logic, we also have another logic called edited key point index. So this is pretty similar to the concept of lock inside the face stretch components. So as you see here, in this face stretch, these indexes are locked. I think they are number 3, number 4, number 9. Yeah, and this one should be number 20, 25, and number 26. And then we have 55, 50, 55, 56, 71, 72. Yeah, and yeah, that's all the key points that are marked as blue, or the key points that are get modified currently in this face stretch components. Yeah, so this array output is what helps you to see, oh, these are the points that are modified in this current face stretch components. Yeah, and I think this is helpful to actually debug and see those points in the real time. And if you take a look into the array, the length of the input and output array, you can see that there is a key difference between the viewpoint and the sample points. Is that the sample point array will always be an array that has a length of 96. So, and then 96 is these 96 points on this face stretch default sample map. And the viewed points array is the array of the points whose position are modified already. Yeah. So if you want to preview the real-time position of the modified points in the 3D space, then you want to use the stretched view key points array and use the index from this edited key string index to see where that point is. Yeah. I know this might be a little bit difficult to understand, but this is the key difference. And most of the time, you don't even need to worry about the viewpoints. It's only helpful if you want to debug this. You see the points, the control point on your face in real time. I'll show you how that works later. And most of the time, you just need to use the sample key points in the same way as we control our face stretch components. To create a really simple set face stretch effect, we can just, for example, we can get the stretch sample key points, which is the key points after you already perform the stretch, and do a set item reference to whichever point you want to modify. So let's say, for example, I want to modify the point for inside this template. For example, I want to move it up and down, and to create some sine wave effects, then we can just change the index of this set array item to number 4, and connect it to the set face stretch component, and connect your face stretch component, and also the default stuff. You can also change the intensity using transit by time, but that's also doable with the pin as well. So let's say we can give a trigger to this set array atom reference, and then we can start to modify the value of these points in real time to see what's the effects of this looks like. Yeah, you may also want to like connect the output of the set array item reference node back to the set phase stretch node so that it can in effects. Yeah. So as you see now, after I connect this one back to the set phase stretch, it's actually morphing my face according to the position of these points. Yeah. Let's say, for example, I just change it to 0, then it will look like this. What I usually do is that I usually use the 2 random nodes to create a random like position for those points. And that's how you see the wobbly face effects, like it's generating the random position of a particular or multiple particular control points. Yeah. Let's say we can combine the 2 randoms together and use that to set this set array reference. So you can see that the number 4 point is randomized in real time in your screen space. Yeah. That's how we create a very basic like set phase stretch node effect. But this is probably just too randomized. So I think a good practice to edit the position is to add a random number to the original position instead of assigning a random number to the position. Yeah. So that makes your changes looks like it's not so abrupt like what I did before. Like it's here and there all the time, but it's based on your previous position. So to do that, you just need to create a get atom from array for phase stretch info, and also using the stretch key points and get the same index from the 96 point array. We can take a look how that feels if we do the previous, just randomly assign a key points to this set array reference. Yes, you can see this point is changing very drastically in real time, and yeah, it's not controlled at all. Yeah. So what I typically suggest for creating a more effective or less valid phase morphing effect is to add this value to this randomizer. And you can also do a multiplier, for example, multiply that by like 0.5 and 0.5, and then it kind of like lessen the effects of the randomizer. And after doing this, you set this value instead of the random value to the phase stretch point. So it looks like, it looks more randomized, the effects. But as you can see here, still the effects didn't last a long time because the point, after adding the position to the point, it just goes all the way up. So to make the morphing effect lasting a long time, instead of adding this value, which is always a positive value, that will drag your points all the way up beyond the screen space, you can modify that by adding a sign function to the XY position of this point so that it can be moved in the local space around its original position.
He just shared a mega tip. He said, when you have a face stretch component click, there's a button called add interactions, and there's already a pre-built-in group called stretch random face under the add interaction button. So you can use this option, or you can also use the add interaction as well. And a lot of people are saying that they haven't tried the wobbly face template before, but they plan to do so in the future.
So just now, I think we're gonna go through the interaction part in the end, but just briefly about how you use all these previous techniques combined to create that one. Yeah, so first of all, we just now introduced how to assign random position to the control point so that it's just randomly popping up in the screen space. But to make it more controlled, my advice is to add like a value to the original key points instead of just assigning a random value. To do that, you can use a sign function that's inputting the time, and then it outputs a range of value from all the way from -1 to 1. So that the position of the points is like a continuous change through time. So to do this, we can first create a tiny little subgraph that lets you output whatever the XY value that changes in a range from the sine wave. Yeah. So to do this, you can first use the guide time from our node system, and this one gets you total time starting from the starting of the effects. As you can see here, it's increasing linearly, and if we plug this one to the sine node, then you can see that the value of the output value from the sine node is actually like doing this sine wave pattern, and it's going up and down, and yeah, it's outputting a value from -1 all the way to 1. So in this way, you can achieve the effect to move your points in the local space of its original position by combining two like sine wave of like value of the time that has passed from the beginning of the effect. Yeah. So to do that, you can actually just assign the sine value to combine it as a XY array. And then instead of assigning the random value, instead of adding the random value to your phase stretch key point, add this sine value to the phase stretch key point, and if you output, and as you can see here, it's popping like up and down all the way through time. Yeah, you can also change the speed of the sine wave deformation by multiplying the time in delta, or by multiplying the speed of the sine wave. For example, we multiply the time by a certain factor so that you can speed it up or make it slower. So for example, if we make it 5 times the delta time, you can see that here, the point is morphing faster than before. And you can also multiply that by 0.5 to make the point deformation more gentle and gradual in this space. Yeah. That's the basic introduction for our phase stretch key points, how you can create the simplest sine wave effect from modifying just one single key point in the phase stretch. And there are some other fine effects you can create. For example, you can also use the transit by time node to control the intensity of the generation, or you can also use transit by time to achieve the similar moving effects of the points. Yeah. Let's say, for example, we can use the transit by time instead of the update to change the intensity from 0 to, let's say, 100, which is the maximum value from the phase stretch, and give it a duration of 3 seconds. And then as you can see, not only you can modify the position of the points in real time, the intensity of the set phase stretch can also be modified in the same time. And you can, what's better than the pin of the intensity, using this approach, you can wrap all of these into a subgraph that you can reuse in other projects. Yeah. So that's basically how we use the simplest functions of the set phase stretch. Yeah. There are also some controller, such as the symmetric and locked index. I'm gonna go more depth into that in the later part of the tutorial. Yeah, but briefly, the set symmetric is similar as the symmetric button in the tool, so that it allows you to control the key point as long as it's symmetric point in the 96 sample space. Yeah. So for example, if you're modifying key point number 4, as we said before, which is this point, and if you have the symmetric clicked on, then if you pick into the edited key point, you can see that point 3 has also been modified. Yeah, this allows you to create the symmetric phase morph effects all the time if you follow this pattern. Yeah, but let's say if you don't have the symmetric option on, and for example, if you change to another point like number 0.16, and we disable the symmetric points, then you can see that there's a, did you see the tiny little dot that flies away? Oh yeah, that's the number 0.16 that is getting more of through time. And you can see its symmetric points, number 17, is not in this index list, which means that it's not included in the phase morph and will not impact the stretch. Yeah, that's how you can use the symmetric option to control whether you want a symmetric phase stretch or you just want an asymmetric phase stretch, which I think in the wobbly phase case, we actually use the asymmetric a lot because we don't want the points to move into the same direction all the time. Yeah. And yeah, this is like another setting that you can modify to control the effects of your phase stretch. Yeah. And last but not least is the locked indices. The locked indices is that you can assign arbitrary like indices of your points to whether to be locked or not. It has a similar effect as this lock option in the tool. Can you see my mouse in the screen? It might be a little bit tiny, but it's actually this one. This, if you click on this lock, then you can see that all the points are locked here. But you can also unlock some of the key points by manually unclicking them to make them like the original display. So this lock is the same as those blue points here in this phase stretch template. So let's say if the original lock index are those 10 points by default, And if you add another point, then those 2 points will be assigned to your locked index array, locked index string. And then you can use these points as the locked points in the face stretch templates. Yeah. And this one takes in string input. For example, if we want to modify this array, let's say we just want to keep the original index array here, then you can input, just click some of them so that it has less points here and it's asymmetric. Okay, cool. Let's say you only want to modify this point, then you can just put in this array separated by the comma to control the which key points you want to modify here. And inside this node, we're gonna parse the exact index that you specify through this node to determine like which point move and which point doesn't move. Yeah. So that's basically all the components of the set face stretch node and the face stretch info node. Yeah. I know this is probably a lot of contents, but I think the key takeaway is always remember that there are 96 points here in the templates, and you can modify those 96 points by using this set array atom reference node. And that's the basic takeaway for this part. Yeah. You can use the viewpoint points to preview the debug points on your face. Yeah. This works for the case where if you have a point in your face and you want to drag it in the screen space and see the deformation in real time, then this technique could be more helpful. Yeah.
Coming up next.
What if I want to see where is my point number 8 in real time in screen space? What's good about this approach is that you can modularize all the subsequent nodes into a subgraph that you can, put into other projects.
This tutorial is making me want to work with the Wobbly Face template right now.